Welcome to Econstruct's online session. So we are dealing with the wind loads. So how to deal with the wind energy or wind analysis, wind load calculations and all. So let's get started. I'll just open the file for you. So if you remember during the last session, we have carried out certain calculations over here. What is P is equal to force upon area. Pressure is basically force upon area, Newton per mm square. Correct? F is equal to obviously what? P into A. F is equal to Cp into Pd into A. What is Cp? The pressure coefficient. Pd is what? Design pressure. Cp is equal to Cpe minus Cpi. So internal pressure coefficient is 0.2, 0.5, 0.7 plus or minus that we have seen during the last session. Am I right? Yes, sir. Yeah. So after this, then you will see the other areas like PD is equal to, what is the formula of the PD? Kc into Ka into Kd into Pz. Pz is equal to 0.6 Vz square. Vz is equal to what? Vb into K1, K2, K3, K4. So yesterday we have seen what is K1, K2, K3, K4. All the parameters. Yes, sir. Right? Pz also we have seen. I think Vz also, this is the formula. Vb I don't think we require to see. Correct? I don't think Vb is required. Anybody needs Vb? This is a basic wind speed. So if you go down, you will see that what is the Vb is all about as per the Indian map. You will get to know the entire design wind pressures that every city that you will be having. See here, this is the Vb, very basic wind speed. So Madurai 39, Bangalore 33, all these things would be the Vb. Understood? Now, coming to the other areas of important things. Kc into Ka into Kd. I think we have not seen that yesterday. Correct? So shall we see that now? Have anybody studied on this? What is Kc, Ka? Anybody? Yes. What is Kc? Hmm. Okay. So it is one of the coefficient. Now how to see, where to see? I'm sorry. So all the values are given in the table already. Have you gone through that? So there are certain values that we will get to know. So let's say for example Kc is 0.9 for example. So it is a numerical value. This is also like 0.91 or zero point 0.9 like that actually. So it is basically you are reducing what? The Pz value. Now from where the hell we need to calculate whether it is 0.8, 1, 1.5 and all, actually we need to look into the different sections of this. So let's search the Kc. Where is the Kc, anybody? So it is the page number 16. 7 point how much? 37.3.13. Huh? One minute. Sorry, this is a PDF, so I cannot do the searching here, guys. Hmm. Yeah, this is the KC value, 0.9. Okay. So when taking wind loads on frames of clad buildings, it is reasonable to assume that the pressures or the suction inside and outside the structure shall not be fully correlated, because it is not an actual balloon, correct? Hmm? बाहर से I mean externally you are applying the pressure inside somebody is doing like this. It doesn't happen that way. So it is that correction factor. So it is not exactly zero point 0.5 minus this one and this plus this or this minus this. It doesn't happen that way. So it is certain plus and certain this minus, but there is a 0.9 relaxation. So 10% relaxation is given. Understood? So the reduction factor of Kc is equal to 0.9 may be used over the building envelope when the roof is subjected to the pressure and internal pressure is suction or vice versa. So what is the value of the Kc we have to take? 0.9. Similarly, yeah, what is Ka and Kd? Okay, now this is the table 5. Table 5 is very important table, guys. Okay, please go through that once. Let's go to the table 4 now. So this is the table 4, which is Ka. The clause number is what? 7.2.2. Correct. So based on the tributary area, the Ka value is getting interpolated or calculated. The linear interpolation on intermediate values of A means Ka is permitted. So tributary area, based on the whatever the tributary area, we can calculate and we can give. Generally, it will come in the range of 0.8 to 1. So either 10% reduction or the 20% reduction. Understood? Now, somebody will say, sir, what is the tributary area? Now, tributary area calculation is also shown here. So, what is the tributary area? Overall structure for evaluating loads on the frames of the tributary area shall be taken it as the center to center distances between the frames multiplied by the individual panel dimensions in the other direction together with overall pressure coefficient. Okay, so these are the certain formulations and all. So for evaluating the loads on frames, the tributary area should be taken it as center to center distances between the frames multiplied by the individual panel dimensions in the other direction. That is basically the overall, you know, the structural area, the tributary area is what actually they are saying it. So how much is ours actually? 5 meter is the distance between the frame and 10 meter is the other side, right? So how much it would be? So how much the value will be? So it would be interpolated. Understood? So please write down what is the value of the Ka, Kd. I hope everybody has written. Okay. Now, what is the next one? See here, all the dimensions are given. So Kd is what? Wind directionality factor. Ka is what? Averaging factor. And Kc is what? Combination factor. Now I think we had seen the Ka. We have also seen what? Kc, right? So what is pending? Kd. So where is the Kd? Yeah, it is. Yeah, so this is the first KD. What is the KD? It is directionality factor. Am I right? So what is that? Considering the randomness in the directionality of wind and recognizing the fact that pressure or force coefficients are determined for specific wind directions, it is specified that the buildings or the solid signs or open signs or lattice frameworks or truss towers, triangles, rectangular, square, a factor of zero point 0.9 may be used for all these particular criteria. So it is straight away saying that you please consider the KD as zero point 0.9. The cyclone effect regions also the factor KD shall be taken it as once. So if it is a cyclone, means it is very high wind pressures are coming in a particular direction. That time only you can take the KD as 1. Otherwise, you can reduce that percentage to zero point 0.9. Means by 10 percentage you can reduce. So in most of the cases, that's why if you remember, I asked zero point 0.9, zero point 0.9, zero point 0.9. So that's how actually it will be that particular factor. In certain cases, I think it is 0.875 something. What is that? Or 0.865. So based on that, actually, we will calculate PZ as zero point 0.6 VZ square and all other parameters. So let's calculate it in the another page. Okay. Now, please, pay attention here. Uh, you are having, this is the frame, this is the building in which, oh, sorry, we are having another rectangle here. Let us say this one, and you are having the other forces also. These things. And here you will be giving these kind of things over here, for example. So imagine hypothetically you are having this kind of geometry. You know that there are frames here, correct? 5 meters, and we are taking this as how much? 10 meters. This is how much? 5 meters. Typically, that is going in this direction. So we'll call this as, let's say, one of the typical frame, which is the middle frame. We'll call it as PF1, which is the maximum number of total frame that is acting on the structure. Now, how much is this particular figure? How much is this figure? How much is this figure? And how much is this figure? That's what actually we are going to calculate. Now, how to do that? How do we do that? So let's see the parameter and just check it up. We need to calculate the pressure basically, which is PD, design pressure. Correct. So what is PD is equal to Kc into Ka into Kd into Pz, and Pz is equal to 0.6 into Vz square, and this is equal to what? Vb into K1, K2, K3. This is the formula. So let's calculate these figures. So we have considered this building is there in Bangalore, correct? So what are the figures? Okay, so Vz is equal to what? 30, 33 into 1 into 1 into again 1 into 1. So 33. So PZ is equal to zero point 0.6 into 33 square. Correct? How much is this? 6 for it? 653.4. So that we will divide it in by 1000. What is the unit here? Newton per. Sorry. So this is equal to 0.653 kilonewton per meter square. Understood? Simple, right? Nobody is feeling complicated, no? Okay, good. Now, once the PZ value you are getting, we will calculate the PD. Now, PD is what? Zero point 0.9 plus into zero point 0.9 plus 0.867 into 0.653, correct? So, PD is equal to zero point 0.9 multiplied by 0.864, right? 67 multiplied by again zero point 0.9 multiplied by 0.653, correct? How much it is that? 0.458 kilonewton per. Understood, everyone? Now, how to apply? Now, this is basically the design pressure coming on this. This is not the force. This is the pressure. So, pressure multiplied by the effective area will give the actual force coming onto this. Do you agree? So, how do we calculate this? So, we need to multiply by the influence area and divided by the length. Do you agree? So let's say PD 0.458, it is acting. Now let's calculate that this force is acting in which particular direction and how it is coming and all. Actually, we'll do that way. Before that, I would like to tell you that how much it is the force, how to calculate the force. We have calculated the PD. This is what we have calculated. I'll just zoom this for you guys. But PD is not you are going to apply. You are going to apply what? Force. Correct. So you apply that value, take the effective force and take the value of CP. Understood? So let's take the CPE and the CPI coefficient. Consider that zero point 0.2 is the plus or minus. 5% only will consider the opening. Is it okay? You can consider 0.5, 0.7 depending upon the project that you are getting. But currently we'll consider only 0.2. Is it okay? Now let's check the CPE value. How much it is? How to calculate, anybody? We have to first find the angle H by W. Okay. So it is L upon W and
only H upon W and theta.
And H upon W. Generally, these are the figures whenever it is a building and all. But currently, this is not the building. This is just the truss. So what would be the value? H upon W. How much is the H? Huh?
8 meters. 8 meters.
Okay. And what is the W?
W is
Okay. So let's see the previous figure now. Now see here, structural height above the, what is the H? Height of the structure above mean ground level, that is the H. Okay, so where actually you are going to find out what and all, actually we'll see that. So we need to take that table. Which table? Table number? Okay. Yes. So this is the external pressure coefficient CPE for the pitched roof. And what is this actually? This is basically for the rectangular clad buildings. This is not for the trusses, cladded trusses. Is that okay, everybody? So please do not consider and get problems to your project. Now let us say for this, how much is this particular figure? What is the H? H is not the total H. H is up to there here. Correct? So let's calculate the H. H is how much? 8 meters. W, 10 meters. H upon W. Now where it is coming? So it will come over here because the value is more than 1.2, 1 divided by 2, but less than 3 by 2. Correct? So this is the case. Now how much is the angle, theta angle? So let's take 20 degrees. In reality, please calculate it generally, okay? How to calculate also, it has been shown it to you over here. So what is the, on the EF? Now there are two angles. One angle is theta is equal to 0 degrees and another angle is theta is equal to. So you are getting what? 0.8 minus, there is a minus and there is a plus. What is minus and what is plus? Oh, sorry. Minus indicates that the force is acting towards the body or away from the body. Force is acting away from the body, and plus is something the force is acting towards the body. Now I'll just confine it with all these figures. So please note down all these figures. Theta is equal to 90 degree, sorry, 0 degree. There is a EF, there is a GH, there is a EG, and there is a FG. Please write down all this. All right. Now let's calculate this carefully. Now this is for the pitched roof of rectangular clad building. So 0.7, which is basically away from the body, 0.5, also it is away from the body. And then there is a GH and FH. This is sometimes actually we'll see that what the hell is about this, how to calculate all this, and what the hell is about this, how to calculate all this. So I would like to tell you that pitch the roof means you will be applying these forces only and only to this portion. Which portion? This portion. EF, GH, EG and FG. Only to these forces. What is EF? What is EG? So look at this figure. EF. So this is the figure. This is the force actually on the surface of EF, and EG. This is the surface, and FG. This is the surface. Okay. So EF means EF like this. When the forces are when the theta angle is zero actually, when this is zero, the force is acting on the EF on this surface. Now, how to show you? Hold on. Huh? So let's say this is the pitched surface. So on this surface, you will apply the force. Now this is minus. Minus means towards the body or away from the body. Away. So whenever you are applying the force to the zero, means in this particular direction, whenever you are applying the forces, this is saying that this is how much? This force is coming how much? 0.7. This is E and F. So all these forces are coming EF. So these forces are coming EF. On this actually this is the case. Now GH. So GH is coming how much? 0.5. Is it towards the body or away from the body? Away from the body. What is the angle actually you will be giving? Perpendicular to the angle over here. So this angle will be the perpendicular angle. Understood? And how much is the figure over here? 0.5. Understood? So it is for the forces coming in this direction. Now I'd like to just copy this to the next. Sorry. Oops. I'll take it in another color. I think that's better. Now let's take 0 instead of 0 it is 90 degree. How much it is? 0.8 and 0.6. Correct? Now how do we calculate the 0.8 and 0.6 in the similar manner? 0.8 and 0.6, and both are coming under negative this thing only. Now somebody will say, sir, what is this and all? Actually, we are not getting. There are local coefficients also which are very high, 1.5 and all. These are basically to take care of the local problem. Sometimes if the huge amount of wind is coming, imagine that there is a gutter here. The gutter will start dag 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 dag. That kind of sound will come. So in such kind of localized areas for the fixtures and all, which coefficient you will be using, which is very very high. It is not zero point 0.8, it is 1.5. Understood? So is it for the everywhere? No, it is for only localized coefficient. And localized coefficient also where it is. So there is a graph here, there is a graph here, there is a graph here, there is a graph here. What is the graph? So there is a graphical representation. Can you see the graph here? There are different graphs. I hope you can identify that. So if something like coming here as I hope that you have gone to see certain sheds very next to this building. You will see that on the roof there is some opening and certain things are rotating. Have you observed it?
Yes.
So to localized connection, nut bolt design and all, actually what kind of connection you will be using, what kind of force you will be using. So this force is this one. How much it is? 0. Sorry, 1.0 minus 1.0. Understood? This is minus 1.0. So that kind of localized forces you will be designing this area. Like that, if certain gutters or certain other areas, panel members, connections, if those kind of things are there, you will take the localized coefficient. Understood? Now we have seen for the pitched roof, this is sloping roof. Now what actually basically will be seeing it for the building? Where is the main building? What is the, oh sir, what is the main building? Oops. Sorry, today my digital pen is not working, unfortunately. All right. So this is the main building. So on the roof, I have identified that 0.7, 0.8, 0.8, 0.6, 0.5, which is plus degree, plus, sorry, 0 degrees and then 90 degrees. Now what about these horizontal places? So let us calculate that also. How much is the force coming here and how much is the force going here? Now from where you will find out? You will be finding out from this one. Understood? So it is the same case. 0 degrees, how much? 0.7, 0.25. Can anybody tell me quickly what are the figures? This we have seen it, I think, at least less than half a dozen of time. More than half a dozen of time.
Nowadays, the Lafond of this happens. Here, maximum is 4 only.
So you have to take the maximum value. It is L upon W is how much? 10. And H upon W? 0.8. So where is the 0.8? Second one. So I'll just remove the other areas so that you'll get certain things. So this is the place that you will be dealing. So 0 degrees. We will take first of all the 0 degrees. So you will be having this figure and L upon W is coming over here, correct? Oh, sorry. Is greater than 3 by 2 and less than 4. Okay, 0.8. So it is how much is the L upon W? L upon W is coming down. Okay, so let us calculate that. How much it is coming. Now what is the L over here? What is the W? Now let's say for example, H is the height, W is the shorter span, L is the longer span. And depending upon that actually we will be giving it over here. Okay, so zero point 0.7, zero point 0.3 plus 0.7 minus 0.3 will be coming to the A and B. 0.7 will come here and 0.3 will come here. Understood? Now coming to the 90 degrees. Now if you see the 90 degrees basically from this side, what would be the forces? This is coming how much? 0.7. This will come 0.1. Understood, everyone? Now there is a once you have got it, let's say 0.7, you will have to consider the internal pressure coefficient as plus or minus how much? 0.2. So internal pressure coefficient will be plus or minus 0.2. So by considering the internal pressure coefficient, how much will be the force? This one is how much? Let's say this is pressure. 0.2, 0.7 will become what? 0.5. Correct? Pressure. 0.3 will become how much? 0.5. It is pressure, no? So it will deduct it from here and it will add here because it is a pressure. Correct? So 0.5, 0.5, and this one will be coming how much? 0.3, and this one will be 0.3. So 0.5 and 0.3. Now suction. Suction, what will be the case? No, no. First one is 0 degrees only pressure. Okay. 0, 90 degrees and all, actually let's not get confused in many other areas. Many a times certain consultants what they do is they take the maximum of the values. So instead of 0.7 and 0.1 they might take 0.7 and 0.7, which is into on the C and D for the 0 degrees only. So that's what H is. A, there is a here, B here, C here, D here. So depending upon that, actually we'll apply the A, B, C, D. And once the pressure coefficients are final, then you will start applying to the actual structure. That's how it is. Pardon? Ah. No, 0.7, right? So because it is at the 90 degrees over here. That's what I'm saying. Some people will take these values and some people will take the worst of the two values. Because wind will come either in this direction or it might come in the other direction also. So they take the worst of the both the values. So instead of the 0.1, actually over here it will become 0.7 for the 0 degrees only. Understood? Now, how do we all this mess calculations happen? For that purpose, if you know that, we can give that actually as a part of the table. So there is a EF, EGFE, and or EGHGH like this, and there can be, you can give the values like this and create the different faces. So A is how much? This figure. This is the intermediate. This is the end. Again, there is an intermediate. This is the end. What is intermediate means? In between. End will be always the 50 percentage of this. Do you agree? Because the area will be reduced by 50%. Correct? Now this is basically at the faces A, B, C, D. These are the coefficients and these are the results. Like that, you will see that WY and the roof. All these figures will be given. Like that, actually, it can be calculated with this particular spreadsheet. I'll give both of them later on. Don't worry. So total building height. How much is total? 8 meter, right? Basic wind speed is this. Risk coefficient 1111. Correct? KD is coming how much? 0.9. KA 867. This is 33. KC forgotten, right? KC is coming 0.9. Okay, now VZ is equal to, what is the VZ? No, wait. I think that spreadsheet, some few issues are there. Just now we have calculated, right? No, not here. It's what we have calculated, correct? Yeah. So zero point 0.9 into 0.867, 867 into zero point 0.9 into this. Okay, so let's see that over here. VZ. Suppose this is okay, so this has been multiplied unnecessarily here. So this is not VZ actually. 33 into 1, 2, 3, 4. That's it. KD and KA will not come. Means 11 and 12 will not come. Third, this also will not come. This is what? How much it is? 13. So VB is perfect now. PD is equal to 0.6 into VZ square. Correct? F15 square. Okay. PD is equal to this divided by 1000, and these are the spans. What is the span now here? Truss span is 10 meter. Length of the building is how much? How much we have said the length?
Total 100.
100 meter. The spacing of the truss 5 meters. 5 meters, yes. So height is how much? 10 meters. No, 8 meters. Okay. Pardon? How much it is? Ah, yeah, this one, sorry. Yeah, so effective area is 10 into 5, which is 50. Yeah, this is PZ. Okay, now what are the percent? I mean, levered and all this, figures. So you can apply these figures over here and get the total amount of how much is the A into PD, and these are the pressure coefficients. These are the pressure coefficients on the what? On the roof, and these are the pressure coefficients where it is. This has to be considered while performing the analysis. And on all the walls, like wall A, wall B, or maybe the side A, side B, like that we need to consider. Okay, so I think they have given it in a little critical way. I would like to simplify this and then give it to you. Is it okay? And because if I give you, some of you would be, because this is CPI, in our case it is coming 0.2, and it has to be first of all positive and then the negative. Let's say here it is coming minus, it has to be minus this. So I am not sure from where these values are getting sensed out. Okay. So I think in the tomorrow session I'll show you exactly the how it has to be calculated. But I hope that you have at least able to understand that how to do that. Before going to that particular place, I would like to show you how it has to be calculated in a little rough way. See, you will be having the load case as W0P. What is W0P? 0 degrees. Wind is W is wind. 0 is the 0 degrees, and P is what? Pressure. You will be having another load case W0N is the suction, or some people they give S. They give negative generally. You can give S also, it doesn't matter. Then next case is W90P. What is this particular, what are these cases? You will be adding into the ITAS model. Got it? Then W90N. Okay, and what you are going to do is, this is, let's say, portal frame 1. What is this? Portal frame 1. On which how much is the force coming here? 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 In all the cases. So here, how many values will be there? 1, 2, 3, and 4 values. Do you agree? Correct? Or 1 or 2 values only? 4 values? Okay, now this is very interesting, guys. Okay, please understand that. if this is the building or the truss which you are having, and this is the ridge line, for example, and you need to calculate the forces. So the major force in which this is acting, and these are the trusses. So major forces, wind force, this is in plan. This is the pitched roof, like this. Okay. So major force coming on this would be here. Do you agree? Now there will be force over here also. Somebody will say 0 degree or 90 degree, whatever the angle it is. So in this degree, do you think that this particular truss will help you? No. Then which truss it will help you? Only this truss and this. Do you agree? Let's say you are having one this truss. In which direction it will help you? In this direction. In the other direction, will it help you? No. Do you agree? Uh, So in this particular direction, only you will be applying the forces to the PF1. That is the point. Now somebody will say, sir, the forces will come here also. Yes, it will be there here, but it will be applied to the PF3. Where is PF1? This is PF1. All intermediate frames are PF1. Gable end frames are PF2. So whatever the forces are there in PF1, it will be just half of the force that will be there in the PF2. Do you agree? Why? Because only half of the force will be applied. Do you agree? आधा ही रूफ रहेगा ना. Here it will be complete roof. Half portion from this side and half portion from the other side. Understood? Got it? See, conceptually समझ लो. Later on, adding the results in the ETABS is 2 minutes job. Literally, it is 2 minutes job. Correct? What to add, where to add is only the problem. So in this direction only you will give the forces 1, 2, 3 and 4. In which direction we will give the forces? Yes, in which direction you will give the force? In this direction. Whatever the 0 degree or 90 degree, based on that shape you find out. Correct? So जो इस direction में forces देंगे, with the forces which are giving to you from this particular forces, only you are going to apply it here on the PF1 and PF2. What is PF3? This is the secondary portal only. On this, you will be giving the forces which are coming in the other direction. Is that okay? That also will be half here and the half here. Understood? Now, how the half is going to get converted is through the cross bracing. That we will see it later on. Otherwise, in today's session, it would be too much. So whatever the force coming here, it will be based on this angle theta, it will be distributed. And the sine theta and cos theta, based on that angle, the force will be there. That particular force will be acting on that, and with the truss analogy, it will be going. Now somebody will say, here is the truss, then what? On the vertically also, there will be the truss. So this truss forces directly will go to the base. Understood? So summation of fx equal to 0, fy equal to 0 and fz is anyway 0. So the forces, it means the forces coming from here, it will transform from the truss analogy and will go directly down. Okay, the forces coming from here, it will be resisted by this portal frame. Matter is over. So this particular frame and this particular frame, because it will be divided by 2. If the two trusses are there, it will be divided by 2. Sometimes we give the truss at the center, so it will not be divided by 2, it will be divided by 3. Okay, I would like to explain you this one more time. Is that okay? Last topic. Otherwise, it's a, oh my god, what the heck. See, first of all, don't take tension, okay? This is the building in the plan, okay? And this is the ridge line. I'll draw this line this time, dotted line, okay? Now, I'll give the other trusses in a different color so that it is more. Now, there are two in the two directions the forces will come. Which are the two directions? 0 degrees and 90 degrees. Just a minute. Okay. Okay, I'll give the forces in some other color. So you will have the forces of the wind coming from this direction, and you will have the forces coming on this particular building on this particular. These are the two principal axes. There is no other force. Somebody will say, sir, force will come from here. Yes, but it will be resolved as a this component and this component with the sine theta and cos theta. So principally, we will be considering the building in the two direction. I mean, in the ETABS also, if you remember the first assignment, we have considered this as EX, earthquake force in X, earthquake force in Y. Similarly, here it is WX and WY. Is it clear, everybody? Till now, at least? Yes, first bench? Yes. Now, I'll call it as W, let's say 0 degrees, and I'll call this as W as 90 degrees. Now, in the 90 degrees, this frame is there. Now 90 degrees means what? You are applying this force to this, let's say I'll call this as portal frame 1. It means the force is acting on this, acting on this, acting on this, acting on this. Now what is the amount? Amount we have seen that 0.6 Vz square, K1, K2, K3, blah, 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 blah. I think you are very good into calculations of that. Do you agree? It is little complex calculation, but it can be done by you guys. So there is a calculation for this separate and this separate. Are you getting? Don't get confused. We have seen the pitched roof and we have seen the building. Correct? Huh? So top roof it is separate and this area it is separate. Correct? Now, again, if you want to me to recall the calculations, you will have Pz is equal to 0.6 Vz square. Vz is what? Vb into K1, K2, K3, K4. Vb is what? 33, whatever the meter square, this thing that you are getting. Okay, then now the CPE coefficient is equal to CPI minus CPE minus CPI. External pressure coefficient minus internal pressure coefficient. So depending upon that, and that also figure you will take it twice. One is pressure, another one is suction. Is it clear? So that data is getting scrutinized with varied variety of different parameters. Tomorrow you are going to do the Excel sheet and show it to me. A small Excel sheet, like the one which I have shown you. This, unfortunately, it is done by somebody. There are certain mistakes are there in that. Okay, but this is how actually it has to be done. So how much is the force acting on this? How much is the force? The force basically is acting either it is, if it is positive force, it will be applied towards the structure. If it is negative force, away from the structure. Is it okay, everybody? Either it is like acting on this or away from this. If it is, this has to be positive, this has to be negative. Is it clear? Now, at least let's say 90 degrees is clear. 0 degrees, are you going to apply here? No. Because 0 degrees is applied in this direction. And this particular structure is not capable of handling it only. So, you are not applying it only. So, you will be applying it on the PF3. PF2 to simple hai. PF2 is only half of the PF1. This is PF1. This is half of the PF1 is PF2. Correct? Yes, that side corner. Understood? Okay. Now PF3. This is PF2. I will consider 50 percentage of PF1. Now the real story comes up with the PF3. Now PF, how many these things are there? Whatever the number of columns are there, that lines will come here. Correct? I'll just draw it like this. Everywhere it will be like that. Now here you need to apply the forces and calculate it. So are you going to take it full as one force, one truss? No, because it is uneconomical. Economy is the basic principle in India. So what you will do is you will consider that, oh boss, I will apply the force and I will make sure that it will come from the structure to the sheetings to the purlins to the roof, through that the sections, from that actually the cross bracings, to that actually it will go to the columns to the foundation. It will not go in this direction. It will go directly from here. I will make sure that it will be transported down. So I will consider only this as the one portal frame. So the force coming here, it will be transferred and it will be coming to the base. So the portal frame is only this, not this big. Why? Because the moment if you say here, actually you will be transported here. The forces will be transported here. If this frame is capable of taking it, the forces will not be transported to the next bay. Is it clear? Otherwise, everywhere you need to give that actually. That will be adding a lot of cost, efforts, energy, and sometimes there is a door here. Then what to do? Correct? No. So all these problems will come arise. Now, how much is the force coming here? So let's say, for example, this is also what is this length? What is the height? So can you calculate the force here and all the forces? Principally understand, man. Then you can figure it out. And tomorrow everybody want me to give. I want everybody to calculate this and give it to me. This is 100%. This is 50%. This is correct. Correct, no? Because half of the area is full area. Hmm? Here also half area. The force will coming here, force will come here, force will come here. So here it will be transformed to this cross bracings. Do you want this frame to take care of this? No. What do you want? It has to transform from the cross bracings. So the entire force, the cross bracings will be designed. Is it for the tension force or the compression force? Both. If the wind is coming here or the wind will come here, in both the cases, the forces under this side as is it under tension or compression? Huh? Tension? Oh my God, too much problem. See, this is rectangular and you are having the this. So if you are applying the force here in this direction, see this would be the reaction will come here like this. Am I right? If there is a force here, the reaction has to come here. So what is this? This sign is compression. Huh? This X component will be under tension. So if this force is coming here, the resultant force need to be giving here. Again, the forces will be giving here. So take one small study. It is very easy to for me to give you okay tension, okay compression. But you study that. Is it okay? How do you study? On paper also, no problem. Is it okay? Otherwise, too much problem will come. Whether under tension or you are under compression or you are under tension. Huh? So simple. If it is tension, you have to design the tension member. If it is compression, you need to design it as a compression. Do you agree? And what is this truss? Whatever the force is coming here, actually, whatever the forces, like this one, let's say this one, this forces, you need to resolve it and design the foundations. That's it. So this one truss you will design, this another truss you will design, which is intermediate truss, the gable end truss you will design, and the matter is over. This later on it is only the sheets and the purlins, and yes, the connections between the columns to beams. Add that details to the StatPro or maybe ETABS or SAP, get the results. It is all later on. It is just mechanical. You go to Dubai, you go to London, you go to America, you go to let's say India, any places. This is how you will design the shed. There is no other way. Somebody will say, "Sir, I will model everything." No, you will go into the wrong area. Let's say from here to PG, you want to go, you will go via Delhi, Agra, all those places you will wander and then you will go to the PG. It's a very long route. And you will see that you lost the route in between. That also will happen. If you want to understand the how to do the modeling, analysis and design of truss, it is hardly 10 minutes job for me to show you. I hope you are getting what I'm saying. Add the channels, angles or eye sections, apply the forces, drrr, it will show you that all the analysis, design, oh wow, finish. Correct? Now here actually you need to calculate what are the forces. Force calculation, the wind force calculation itself is a tricky. Do you agree? And it is tricky. It is not difficult. Please understand. K1, K2, K3, K4 all are 1, 1, 1, 1 most of the time. or maybe point. See, it is 5%, 10% discounted only some places. Correct? Uh, Somebody is saying that okay, this is under this area. Okay, you take 5% discount. This is under this. Okay, take 10%. That's how it has happened. Okay. So all these multiplications will come and it will give you certain pressure value. Once the pressure value you got it, you know the area. What you will get? The force. That force you need to divide it by length. You will get the kilonewton per meter. And that kilonewton per meter, you will apply that in the ETAS model or STAT model, SAP model, whatever the software that you use.
So what it means to inclined member.
Inclined member. It is always the incline, not the gravity force. It is always the local axis, perpendicular to the local axis. Yes. Understood? So tomorrow I want one small spreadsheet from your side. Don't take this spreadsheet because it is there are so many mistakes are identified. Okay, and you please send me on the WhatsApp personally. Don't send it on the group. Sir, we two people have carried out that. Don't do that. Okay. Somehow, to be very honest, if you give me the piece of paper and pen, it is very simple. On this digital, looking into the code and all, it becomes a little complex. I hope you are getting my point. But it is only, I used to calculate. See, believe me, when I was there in Dubai, we used to calculate only shed. It's so boring over the period of time. So, how do I used to calculate? Also, I'll show you. After everything, we will get what? The PD, the pressure coefficient. Let's say, for example, 0.675 kilonewton per meter square. Then W at 0 degrees implies 0. 0.8, 0.7, 0.7, 0.5, 0.6. W at 0 degrees, this is P, 0 degrees and implies, let's say 0.8, 0.5, 0.4, 0.9. Once this is done, this is for what? PF1. PF2 is what? 50% of this. PF3. What is PF3? This is the case. Then you will apply whatever the force, and whatever this force actually, based on that you will create this portal frame, this portal frame and this portal. Only 3 portal frames, entire shed is done. And generally, if you ask me, this ties actually, if it is under compression or something, you will give that channels or angles. If it is coming under tension, you will give the rebars. 16 mm, 20 mm rebar. Bar ही लगा देंगे. Okay, that's how it is. So you give the cross bracing, you design the total frame, and finish it. So why we are using this intention? It is good intention. No, that's okay. In the compression, can you give rebar? Understood?
I sections are not good in
No, comparatively, yeah, it is good into tension, but sometimes depending upon what is the value coming there. Correct? See, the area is small, right? And that also you are dividing into 3 areas, 3 parts. So amount of force is very less. That also you need to divide it by that angle. The force will be hardly, 12 mm, 16, 12 mm nobody gives, but at least 16 mm bar will come, matter is over. Ah, you add it, tie it, tuck, tuck, finish. It will be done. Later on, you can become Mouser and do and check also whether everything is okay. There you cannot check, but in the model you can check it. Yes, simple, no? So ultimately you are going to design based on this. So point 0.8, point 0.6. Now what is point? How to add the point 0.8 and all actually? These are coefficients. Point 0.8 will be multiplied by what? This figure. So you will multiply with this. So then later on, these are the coefficients. Later on, you will calculate the values and add that values in the model. Analyzing, designing. Got it? Online guys, are you getting?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. Is it simple? Say simple at least. Simple, eh?
No, no, sir. Partially simple, sir. Honestly.
Partially simple. Okay. See, this is the first time actually you guys are going through that. Okay, and believe me, from teaching side also it is little tricky. Why? Because I had to look into this one note, the another code, then the software and too many different things. Actually, it is easy for a piece of paper and pencil. Got it? That's why I'm requesting you to do it manually. In 0 degrees and in the 0 degree. Let's say for example over here, what is the effective area? You take the 50 percentage from here. Let's say this is 5 meter. So how much is this? 2.5 plus 2.5. So effective will be 5 meter only. Yeah. At the gable end, at this frame, effective area will be 2.5 only. Because half it will go to the PF1. Half only it will come to the PF2. So effective.
Need to multiply with that. Means 5
Which this length?
No, sir. That 2.5 plus 2.5 will be there. That we need to multiply with certain length.
That's what the coefficient. Whatever the coefficient you are getting multiplied by the pressure, okay, and multiplied by the effective area. A is there, no, in the multiplication. You have forgotten or what? A, see here. F is equal to P into A. So F is equal to CP into PD into A. So A has to be multiplied anyway.
So we have to multiply by distance effective
Ah.
distance into this length.
Into this length and divided by the into area and divided by the length, because it will be uniformly given, because this is the force.
Area is 5 into 8, sir. The length
Huh?
in our problem area is 5 into 8. 5 into 10. 5 into 10.
So effective area, it is 5 meter like this, okay, and depending upon that actually the pressure will be there. Now if it is coming on the pitched roof, then you need to see that how much is the pitch roof length here and the pitch roof length here. Okay, but where it is coming to the building, for example, then you will see what is this area. This is the length and this is the height. So this is the area. That's what actually. So let's say over here, you will multiply. Let's say for example, half of half. Imagine that this is your portal frame. So you will take this distance. How much is this distance? 5 meter. This is this distance into the total span. How much is the height? 8 meter. So 5 into 8 multiplied by PD.
And when we want to convert that into area,
And that divided by whatever the length is coming. So let's say for example divided by it. So generally it is 5 into this thing only will come. Understood? No.
they have given directly back.
No, that's why I'm giving multiplying and again I'm showing you division also.
Now we got.
I know that it is confusing. To me also, when I first time when I've entered in Dubai, this all monster was welcoming me because I never done the uh, the steel structure in India before going to Dubai. So it was, oh my God. Here I done almost 25, 30-story building in India when before entering into Dubai. But when I entered into Dubai, there was no RCC, only 40-story one building was there. That I completed within hardly 2, 3 weeks. Then next what? All were the shed. Almost 6 months I was calculating only sheds. Almost like 20 sheds I would have finished. Understood? This is how it's a simple thing. I'll tell you very honestly. You keep this attention for at least minimum 2 weeks. 2 हफ्ते में उसका पूरा निकल जाएगा पूरा गन्ने का रस निकल जाएगा. The sugar cane juice will be outside. There is nothing left out. Within how much time? 2 weeks. Because entire this all the topic which I'm trying to show you here, it is 10 percentage of the first chapter of the M1. Understood? Yes. इतना ये simple है. It is only like you are thinking it little complicated, or this is the first time you guys are watching it. That's why it is feeling a little complicated. Got it? And the extension of all these things would be always there. So let's say there is a structure like this. So then there are forces like this. Well, anyway, there are some permutation combinations for such kind of structures would be there eventually later on anyway. But the moment you understood that this is one frame only, then you don't need to bother on that. Conceptually, all everything will remain same. You work basically, do not go into the subtle areas. You work on the gross areas. Macro level of analysis you work. Micro level, whether this point into this, into this, into this. Eventually it will come out well. Got it? There are some videos are also there on the net. You can go through that. You can watch my video also. You can go through. There is a. It is available. No, no, no. It will be available. Today you'll get it. You ask him. I have uploaded. He was not knowing what is the path. That was the issue. That has been resolved already. So you'll get last 2 months videos also. Don't go to that 2 months. You watch at least 2, 3 days before videos and start working. Or maybe instead of watching my videos, you can go through the code book, which is more, scientific. Another thing is one of the IIT professor from Kanpur has given the literature, very good authentic literature. That also you can go through that. It is already uploaded on the digital library also. Please go through that also. Okay, so it is very simple. One in this direction, another one in the other direction. One is on the pitched roof, another one will be on the building. There is a pressure, there is a compression, and there are coefficients. Coefficients are multiplied by various different parameters, topographic parameter, this parameter, that. That's all it is. 3, 4 different concepts are only there. Understood? And once I'll tell you 2, 3 shades if you know na, that the third and fourth step actually you don't need to even think about it. Yes, there are some gantry girders, plate girders, and other things are there that anyway will not go that deep into the subject. Okay, because eventually when you go to a company, you will know the fundamental mechanism. Then later on they will help you to understand what are the loads and all. So basic principles will make it clear over here. Have you understood what I'm saying? The gantry girders means, for example, here there is a crane which is going here and coming here and all. So there would be the combinations of the crane going here. So maximum shear force on this point and to the other point. You need to calculate, and plus on the other subject. That is not related to the wind load. That is only related to the dead load and crane load. So that part is comparatively simpler. That you can, clear it when you go to different companies. You need not have it now, but conceptually will help you to understand. Got it? Okay, any questions? Yes, online, offline, guys. Hello, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sometimes I forget that you guys are there. At least you say something, okay? So I hope the online people are able to understand. No need to come here. Offline से जब जरूरत में I can able to take it. If you guys are feeling problems that oh my god I am not able to get any damn thing and all, you can ask in the DCAs and in the other sessions. Okay. Still, if you are having problems, you can ask us, or you can come down here at least for 2 3 weeks, maybe 2 3 months, or maybe 7 months. Okay, but if you guys are able to take it up, good, no problem. Okay, because traveling nowadays also is becoming a little. थोड़ा दुआ करो यार कि कोरोना बढ़ नहीं जाए. हाँ? You given the deadline to them, huh?
Because last 2 years, March में ज़्यादा peak पे again
I don't know. All right, guys. So thank you very much, everybody. We'll see you tomorrow, same time, same place. Thank you.